Hi, my name is Stephen, and today I will be discussing PCR as part of our Laboratory Skills program. To begin, genomic DNA must be isolated from your sample. If you are working with tissues, use the QIAGEN tissue lyser to disrupt the tissue. Do this by adding your tissue to an Eppendorf in the lysis buffer of your choosing. Then add one metal bead to each Eppendorf containing your tissue. Add your samples to the tissue lyser adapter that has been pre-chilled on ice. Pre-chilling is important due to the heat generated by the tissue disruption. Carefully place the tissue lyser adapter with your tubes into the tissue lyser. Tighten the cap and ensure it is secure. Adjust the settings appropriately. Results here will be analysed on a 1% agarose gel. Here we are adding 1 gram of agarose to 100 ml of 1x TAE buffer. Once added, heat in a microwave until agarose is dissolved in buffer. Be careful as agarose can become superheated if microwaved for too long. Put on heat-resistant gloves and carefully remove the conical flask and swirl. Next, assemble the casting platform, ensuring there are no leaks. Add a comb to the rig, ensuring there is enough wells for your samples. Once the agarose is dissolved, allow a few minutes for the agarose to cool and add a DNA staining agent. Here we are using Nancy. Carefully pour the agarose solution into the cast. Pouring the gel while it is too hot can cause the cast to crack. Allow the gel to set for at least 1 hour. Next, make a master mix that contains the forward and reverse primer for the DNA region of interest, along with the Taq polymerase enzyme. The concentration of forward and reverse primers will have to be optimized for each DNA region of interest, but 100 to 200 nanomoles per reaction is a good starting point if the reaction has not been previously optimized. You may have to centrifuge your samples at 12,000 G for 15 minutes at 4 degrees Celsius to remove unwanted cell debris. Next, transfer your lysed samples to tubes that are compatible with your thermocycler machine. Add the master mix containing the concentrations indicated by the supplier of the Taq polymerase to each of your DNA samples. Next, place the samples in the thermocycler. After the run is complete, remove the samples from the thermocycler. The cycling conditions consist of a denaturation stage, an amplification stage, and an extension stage. The denaturation stage is 2 minutes at 95 degrees to separate the DNA into 2 single strands of DNA in order to allow the primers to bind. The amplification stage requires cycling between 3 temperatures: 30 seconds at 95 degrees to separate the DNA into 2 strands, 30 seconds at 58 degrees to allow the primers to bind to the DNA region, and 1 minute at 72 degrees, which is the temperature at which the Taq polymerase will bind to each primer and make the new strand of DNA. This amplification stage needs to be repeated 30 to 35 times. The final extension stage is 5 minutes at 72 degrees to ensure the Taq polymerase has extended all available primer bound. Add the loading buffer to each sample following the supplier's recommendations. The agarose gel can then be added to an electrophoresis chamber and filled with TAE buffer. After removing the cone, load each sample into a different well of the gel. A DNA ladder can be included if the size of the DNA fragment is required. Run the electrophoresis at 100 volts for approximately 1 hour. Following electrophoresis, DNA can be visualized on a UV imaging machine. Remove the tray from the imaging machine and clean the tray. Place the tray with your gel into the lower half of the machine and close the door securely. Using the software, select the fluorescence tab. Ensure the UV icon is selected and click Start. Following exposure, you can adjust the image. First select Invert, then adjust the contrast and use the zoom settings to visualize your bands. Thank you for watching this module on PCR as part of the Laboratory Skills program.